In the last video, we looked at quadratic functions and just kind of got a little bit of playtime with Desmos and kind of explored what the different things did in the different forms of a quadratic function. Now we want to be able to produce a graph of a quadratic function without graphing utility help. We can confirm with a graphing utility, but we want to be able to do it on our own. Okay, so when I think about graphing a quadratic function, I really think that every graph should have 5 key features. And so on the right here, you'll see a sample graph. Okay, and so first big thing is that the shape. Okay, when I think about a quadratic function, it should have a particular shape. It should make a parabola. That's what this U-type shape is called. It's not a perfect U because you don't have the little tail down here, but then also it doesn't make that full bowl like that. Okay, so this shape is called a parabola. Okay, and there's a maximum or minimum value, right? And it has to be rounded. Okay, if this is sharp, like a V, I am going to take off points. Do not make it sharp. Okay, if it's sharp, it's more like an absolute value graph. So don't do that. Okay, so make sure that you have a nice rounded value at its maximum or minimum. And also keep in mind that a parabola can open down too. We saw that happen briefly in the last video. So it can open down. Okay, speaking of opening, that's the second thing. Parabola should either extend upward or downward from this minimum or maximum value. Okay, and so how we know what is kind of from the algebra. Okay, and we remember that this is like f of x is equal to ax squared plus bx plus c, there's a variety of forms, but all of them have an a, and that a is going to indicate whether it opens up or down. If it's positive, if it's positive, it's going to open upward. If it's negative, it's going to open downward. Okay, so that's 2 things down, 3 to go. Next is there should be one minimum or maximum value. Okay, in this case, my minimum is going to be here because it is opening downward, or opening upward. So when you have an open upward, you're going to have a min, and then when you have an open downward, it's going to be a max. Okay, and this minimum or maximum actually occurs at what we call the vertex. Okay, and then the vertex, we can find it by, again, if it's in vertex form, it's just at hk. Otherwise, mathematically, I can go through a lot of derivation and all that stuff. But what we get is an x value of minus b over 2a. Okay, and then for the y value, there's a big complicated formula that you can memorize. I'm just going to say, doesn't it make sense if you want to find the y value associated to an x that you put the x value in and find out what y is? That's all this means. Okay, so take x in, so find y by plugging in, and I guess substituting in. I have an issue with plug in because you plug a cord into an outlet, but plug in x. Okay, that's all this means. Okay, and I'll also mention that the minimum or maximum is the y value. So if you're ever asked about the min or max value, that's your y. That's the y value of the vertex. Okay, so great, we got a lot of things done. We got more to do. Okay, and so the next thing that we can notice is that, so this is 0, 0. Next thing is that this graph, it's symmetric. In fact, if we were to take a line of symmetry that goes directly through the vertex, this is actually called the axis of symmetry. Okay, and it's a vertical line. And we know every vertical line has the form x is equal to, in this case, 0, but it's just going to be the x coordinate of your vertex. So in this case, it's going to be x is equal to minus, oops, why isn't it showing up? There it is. Minus b over 2a, or x is equal to h. Okay, same thing. All right, so be aware of that. And then the last thing is that here there should be, or I guess every quadratic function, we talked about increase and decrease intervals. This one is going to have, or every quadratic function is going to have one interval of increase and one interval of decrease. So on mine is going to be increasing on 0 to infinity. And really, we don't, we don't generally include that, so I always do open brackets. You can't have increasing or decreasing at a point, and decreasing is going to be minus infinity to 0. Again, if you communicate square bracket, I understand what you mean, but it's technically mathematically wrong. All right. In any case, here are the 5 things: shape, direction of opening, min or max at the vertex, axis symmetry, intervals of increase and decrease. Now, that isn't all, but those are the key things, okay? So we're going to go ahead and do an example, okay? So it says obtain a sketch, blah, 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 crap ton of stuff to do, okay? And it said check your answer using Desmos, okay? So first thing I want to do is I want to get this as something that I can actually use, because this is not in standard form, this is not in factored form, this is not in vertex form, so it's not useful. Okay, so what I'm going to do is I'm going to use my math skills and expand this all out. I get 2x when I distribute plus 16 minus x squared minus 8x minus 9. And so what do I get? Minus x squared minus 6x and then plus 7. Okay. Or equivalently minus x squared plus 6x minus 7. Okay, so that's my y value. Okay, so now from this, you might need to do a little bit more work. I'm going to tell you that this ends up factoring quite nicely as x, go back, there we go, x plus 7 and x minus 1. Okay, which is factored form. Okay, so then that tells me that if I were to make a graph, okay, this is going to be not quite to scale. 1, 2, 3, 4, 5, 6, 7. Okay, this is going to tell me I have one intercept at 7, 0. So I'm just going to make a list of things. Negative 7, 0. And because again it's that minus 7 idea. And then I get the other one at 0, 1. Or 1, 0, sorry. Okay, and then let's see if I put in, let's see, and it says labeled points, so I should probably label these. So this is minus 7, 0, this is 1, 0, and then if I put in 0 for x, so I would put 0 in for x, and I find that y is 7, so, yeah, that works, right? Yep. And so I want to plot that point. This is not going to be to scale. Let's see, so I'm just going to say that this is at 0, 7. Okay. Okay, so now all the key features, let's see, so I need the shape, which I need to get, so I can't do the shape right now. And then the next thing is to find the direction of opening. So I'm going to say it opens down, since a is equal to -1, which is less than 0. Again, that's where you determine the negative. Okay? And then let's see, what else after this? So then the next thing is to find the vertex. Okay? And so this is going to be x is equal to, now this one I had in standard form here, and I had in factored or root form here. Okay, I'm going to look at standard form, and in that form, again, a is -1, b is going to be -6, and c is going to be 7. So then if I do negative b over 2a, that's going to be 6 over 2 times -1, which is -3. And then to find y, I would take -3 and substitute it in. So -3 squared, careful of your parentheses, -3 plus... Yep, plus 7, and what I end up getting is 16. Okay, so that's going to be at -3, and I'm going to plot that point on up at 16, so something like right there, 3, -3, comma 16, and then since it's opening down, this is going to be my max. Okay, all right, so then I can make, just so I'm aware of the shape, I'm going to make a little U shape near there, just so I know it opens down and communicated maximum and all that. Okay. Then next thing I'm going to label the axis of symmetry, and I'm just doing that as AOS. And that is going to be a form of x is equal to, and then whatever your vertex, your x-coordinate of your vertex is, so minus 3. So that's a vertical line progressing right through minus 3. And again, that's not a straight line. Imagine it was, okay? But now the idea of symmetry, the axis of symmetry, is if you have a point. So, for example, we have a point here at negative 7, 0. This is 4 units away from the axis of symmetry. I can go 4 units on the other side, and that'll give me my other intercept, which is what I already have at 1, 0. Okay? So then, by that same logic, if I look at this, the distance from my horizontal intercept, or my vertical intercept, that's 3 units from the axis of symmetry. Well, then that means if I go 3 units over here, this is going to be another point, which happens to be at minus 6, 7. Okay? And again, I just did 3 units from negative 3. Okay? And so then that kind of completes my parabola type shape, and I'm just going to kind of fix this a little bit so it looks a little bit less awkward. Okay? And that's going to be the graph. Okay. The only thing else I have to do is talk about increase and decrease intervals. Okay. Now, increase is the idea as you go from left to right, is where is it rising? And in this case, it is rising from minus infinity to minus 3. Similarly, for decrease, that is as you progress from left to right, where is the graph falling vertically? And it is falling vertically on the other side, so from minus 3 to infinity. Okay? And that's going to be the end of our example. Again, a little bit longer video, but hopefully it has enough details in here that we need. And again, if you wanted to check using decimals, feel free. And there's going to be a quiz question right now that just kind of outlines one of the key aspects of quadratic functions and their graphs.